Hello everyone, welcome back to That Cyber Guy. Today we are breaking down quantum computing in the simplest way possible. So we're gonna talk about what it is, how it can crack certain passwords dramatically faster than classical computers, and how new technologies like post quantum encryption and post quantum cryptography will keep us safe in the future. Now, are you ready to understand what quantum computing is? Buckle up and let's get started.
Learn cybersecurity in no time.
Now, every device you use runs on bits, tiny switches that are either a zero or a one. So classical computers are incredibly fast, but they need to get something like password. They check possibilities one at a time. But quantum computers use qubits, which can be 0, 1, or both at the same time. This is called superposition. And when qubits interact, they can become entangled, letting them work together in ways classical bits never could. So this lets quantum computers explore many possibilities simultaneously, giving them a huge advantage for certain type of problem. Now, let's look at it as a real world example right here. Great news! So we updated that cyber guy. As you can see, you can just come here and explore all our cool tools. So now let's just check out that password chef right here. So before I just have a demonstration, so let's just explain something here. A classical computer might guess 10 trillion password per second. You might think that's huge, but for a long password that can still take days, years, or even centuries. So quantum computers can use something like the Grover's algorithm, which gives them a square root speed up. So this means instead of checking all possibilities, they can find the answer in roughly the square root of the time. So a password with about 3.6 quadrillion combination may take a classical computer days, but a quantum computer could reduce that then to less than a second. So this is why quantum computing is such a big deal for cybersecurity. Now let me just take a pause here. Let's just come here. I'm going to type a password. Let me make sure that I just turn this on so you can see what I'm typing. Let's see. Okay, let me make sure that it is on. There we go. I'm going to try to type a password. As you can see with our new tool, you can actually, as you're typing, let's say password, let's say dog. Okay, okay. Okay, let's say dogs. One. See, I'm trying to just, trying to see. As you can see, classical computers, a password like that is very strong. Like in today's security, we are like, okay, make sure that I have like a capital letter, a small one, special character, and numbers. So for computers today, it will take 95 years. But look, for quantum computers, it's gonna take less than a second. As I explained, we this is like using that the Grover's algorithm. So let's just keep moving. I'm not trying to scare you, but let's just keep moving. Should you be worried? Not yet, because today quantum computers are still experimental and nowhere near powerful enough to break modern encryption used by banks, government, or your phone. But we are preparing for the future, and that's where post quantum encryption and post quantum cryptography comes in. So let's just explain what they are. So, what happens when quantum computers eventually get strong enough to break today's encryption? So, what we're gonna do? We're gonna upgrade the locks. So, post quantum encryption or PQE. This is the goal: encryption that stays secure even if a powerful quantum computer tries to break it. Now we have post quantum cryptography or PQC. It's a technology that makes this possible. It's a new family of cryptography algorithm designed to resist quantum attacks. Instead of relying on old math problems that quantum computers can quickly solve, as you can see here, because this is an old math problem. That's why the classical computers couldn't just resist. But PQC uses completely different mathematical structures, things like letters based cryptography, hash based signatures, or multivariate polynomial systems. These are the problem that even quantum computers struggle with. So why this is matters right now? Organizations around the world, like bank, browsers, cloud providers, government, are already preparing for transition. Standards like the NIST have selected the first official PQC algorithm, and over the next few years, they'll quietly replace all the system behind the scene. For most people, this upgrade will be invisible. Your apps, your website, and device will simply update and become quantum safe automatically. Now, what you need to do in today, how do you protect yourself? Use a long password. Let's see here. So let me see how many characters that are in my password. I don't know how many, but the more your password, if you're using more, that's insane. You see how many passwords I'm using here? That is very insane. That's a very insane password, but okay, it's gonna take 10 years if it's visit that long. So you see that if you have like 12 to 16 characters, mix them with upper lowercase, and no, do not put your names, birthdays, or common words. You can use a strong password manager, and in fact, we have another tool as well. For a password manager, if you want to just have a password generator, you don't even need to just think about password. You want 30 characters, you just generate it. Bing. And if you were to just copy this and go back to our quantum, let's see how long it's gonna take it. Oh yeah, there's no chance. So this is how you can just say protect yourself, at least 10 to 12 characters. And if you cannot create password or just cannot come up with any password, you can use our tool. Come here and then try to just enjoy our tool. Now, as a conclusion, your quantum computers won't replace classical computers. So there's no way it's gonna replace it. Because classical computers, they are built for different kind of problems, but quantum computers will reshape cybersecurity. So by using strong password today and relying on post-quantum encryption and cryptography tomorrow, you'll be ready for what the future brings. Now, if you enjoyed this breakdown, hit the like, subscribe, and tell me what tech topics that you want to simplify next.